if you had something like y equals f of 3x, your x value would get multiplied by a third. And so everything inside the brackets is opposite of what you would think, and we would call this a horizontal compression by a factor of 1/3. So whenever we're describing stretch or compression, we always write by a factor of and exactly what we would be multiplying by. And anytime you're multiplying by something less than 1, it's going to be a compression. So if you had y equals f of 1/8 x inside, this tells us we would multiply x by 8, and we would call that a horizontal stretch by a factor of 8. So one of the themes that starts to happen with what happens inside of a function is that's sort of opposite of what you see, right? Plus 3 moved it 3 to the left. 3x multiplies by a third, not by 3. So if we can sort of have that as a pattern that inside the function sort of acts differently and outside the function acts the same way that you see it, that can help you remember this. So when we get here to example 2, we have the graph of g of x, and we want to sketch the graph of 0.5x. Okay, we notice this 0.5x is inside the function. This is going to be a horizontal stretch. You're going to multiply your x values by 2. You can think of 0.5 as a fraction. It'll be much easier to multiply by the reciprocal if you do that. On the red graph, I've got a bunch of points. I've got the point -3, 2. I've got the point 1, 5, 3, 3, and 4, -2. Those are the 4 key points on the red graph. And so if I need to multiply my x values by 2, again, above the arrow, I write out what it is that I'm going to change. I'm multiplying my x values by 2. Well, that's going to change this one to -6, 2, 2, 5, 6, 3, 8, -2. Where do those end up? -6, 2. Ooh, okay, perfect. Did you see the mistake I made? It's tiny. What did I do? It's -1, 5. And this is probably a good example of what's going to go wrong for you over and over, and I'm warning you. You will make so many little mental math errors in this unit for 2 reasons. The mental math is super easy. And because it's super easy, like, what did we have to multiply by? 2. Is that hard? No. And so while you're doing it, you start to daydream. Because it's easy, you know it's easy. And all of a sudden, in between, you're multiplying your x values by 2. Pretty soon you're multiplying your y values by 2. Oh, sometimes you multiply everything by 2, right? Because it's easy, you start to pay not as much attention, and then things go wrong. They say most people have car accidents closest to their home more than anywhere else. Well, that could be for 2 reasons. One, you're driving closer to your home more than anywhere else. I have never had any car accidents in Australia. I've never been to Australia. Okay? But 2, because When you get close to home, you're like, this is easy. I know where I'm going to turn. I know what this is like. So you start thinking about other things, and you're not paying as much attention, and you make more mistakes. So yes, multiplying by 2 is easy. Labeling coordinates is easy, but I forgot a negative. So sometimes, even in these easy things, we have to pay extra attention so that we don't have mistakes happen. I noticed it because I knew what I wanted to happen, and when I went to label -2, 5, it didn't seem like I had stretched it horizontally by 2. 3, 3 went to 6, 3, and 4, -2 went to 8, -2. Join the dots, and this is our graph stretched. The one point that doesn't change is your x-intercept, because your x value would have been 0, and multiplying by 2 wouldn't change that. When we say a horizontal stretch, it's like you grab the function on either side of the y-axis and pull away. That's how it stretches. And it pulls away from the y-axis. So we look at this point at the bottom. It's 4 away here, and now it's 8 away. It's been doubled its distance away from the y-axis. Domain and range of these functions, I'm going to use interval notation this time. The smallest x value to begin with was -3. The largest x value to begin with was 4. In my range, the smallest y value was -2. My largest y value was 5. On my new blue graph, my domain is now -6 to 8, but my range stayed the same. The same idea. Your x values have been multiplied by 2. Can you see that in how your domain has got changed? Your domain both got doubled, and your range didn't change because nothing happened to the y values. Okay, so you have question 3 from the first one, and now you can also do questions 4 and 8.